In this video, we'll talk about product and quotient rules for the derivatives. Unfortunately, they're not as easy as power rule, constant multiple rule, sum and difference, and so on. So I'll demonstrate the product rule first if we're trying to take the derivative of the product of the two functions. The way to do it, the way I remember it, is to take the derivative of one function at a time. I typically start with the first one, so the derivative of the first one times the original second, plus keeping the original first one and then taking the derivative of the second one. So it turns out that this rule works. There is a way to derive it and show it that it works, but we're going to show it via an example of a very simple product where we could have distributed. Here is one where h of x, again, we can quickly distribute it and compare it. So we'll have, let's say, x plus 2x squared. But we're going to check and try to use a product rule and see if it actually works. So if we do avoid it, notice how I've multiplied it. We take the derivative. Derivative of x is 1. Derivative of 2x squared is 4x. So we get 1 plus 4x. Now, what if we try product rule? Notice I actually even color-coded for you guys. So if we think of x as the first function, f of x, and 1 plus 2x as g of x, the second one, then how do we take the derivative? So derivative of the first one is 1, and keep the second one the same, 1 plus 2x, plus keep the first one the same, x, times 2, which is a derivative of g of x. Then we get, if we distribute 1, we'll get just 1 plus 2x, and then here this term just becomes 2x, and so we get 1 plus 2x is 1 plus 4x. Notice how we get the same result in both ways. What, however, does not work is taking derivative of both of them, if we backtrack a little bit, at the same time. So this is the wrong way of doing it. We do not get the same result if we take the derivative of both of them at the same time. You'll get 1 times 2, which is 2, and that's does not work. So you do not want to do it. It does work to do it of one at a time. Again, I usually take the derivative of the first one just because it helps also for quotient rule and chain rule a little bit later. So let's practice this a little bit. So what if we have a similar one where we could have distributed, but let's not. Let's use the product rule. X cubed times 1 minus x squared. What do we get? Then again, if we take derivative of the first one, it's 3x squared times the original second, 1 minus x squared, plus x cubed times derivative of 1 minus x squared is negative 2x. Then we again distribute, and here we actually do have to distribute. So get used to simplifying the simple ones. And sometimes we don't have to simplify it, but in this case we do, just because it's simple. It's 3x squared, and then we can combine the 2x to the fourth, so we'll get minus 5x to the fourth. And we can do the same thing if you have a function squared. We don't know chain rule yet about the composite function, so we can separate it as a product and do it that way. So notice how we basically, now it's the same derivative 4 for either one of them. So you'll get 16x minus 4 plus 16x minus 4, so that will give us 32x minus 8. And we can do a similar example with radicals. Notice x squared times square root of x. What if this is the original function that's given to us? Well, we can rewrite it as x squared times x to the 1/2, and now it becomes a product. So how do we take the derivative? That would be 2x times x to the 1/2. We'll keep the second one the same, plus x squared times the derivative of x to the 1/2 becomes 1/2 x, and then 1/2 minus 1 becomes negative half. So we get, now we can actually simplify it a little bit. How do we simplify? Here if we put a little 1, then we have 1 plus a half. That's how we get 3 halves. So it's 2x to the 3 halves, plus 1/2 can come to the front. And again, it becomes a 3 halves. How do we get that? It's 2 minus a half. So you'll get 3 over 2. So it's 4 over 2 minus 1 over 2. We'll get 3 over 2. Now notice they're both the same power, so we can actually combine them. How do we do that? We combine the 2 and the half. 2 and a half basically is 4 over 2 plus 1 over 2. That would give us 5 over 2, x to the 3 halves. And you can simplify it, as you'll see. It's common in the homework. How do we do that? We keep 5 in the numerator. The x to the 3 halves, basically the half becomes a square root of x cubed over 2. Yeah, you could have simplified it further, but for business calculus, we'll keep it this way. Just make sure you get a radical, because originally there was a radical. And that's it for that one. Now, quotient rule. It's a little bit more involved, but notice how it is similar to product rule. Not to be confused. What are the differences? The denominator becomes denominator squared. If you think about the derivative of 1 over x, and this is your function, what is the derivative? Well, it's negative 1 over x squared. We're not going to worry about the negative too much, but notice how you will get x squared in the denominator. And I'll let you figure out how I get that. But so we do get denominator squared. I usually remember that first. Then what do we get in the numerator? Again, I think of it as derivative of the top, here is the f of x, times original bottom minus derivative of the bottom times original top. There are certain acronyms and so on. I'm sure you can find them online that you can use it to remember, but I just remember, again, start with derivative of the top, then you alternate them. There is a minus. I remember minus for division instead of a plus, like product rule. So let's see some examples. We'll start with a relatively simple one. Y equals 2x plus 4 over 3x minus 1. How do we take the derivative? Again, I usually start with denominator when I'm first setting this up. So I'll get 3x minus 1 squared, quantity squared. Good news is it's rarely that we have to expand the square on the bottom. It would not be wrong to do that, but it's okay to keep it the same. Now, derivative of the top, we'll just get 2 times original bottom, 3x minus 1, minus. Now notice I switched them around a little bit. I put the derivative of the bottom first just because it's easier to distribute. So minus 3 times the original top, 2x plus 4. Again, we can just simply distribute. You know, same thing with the 3 and the 4. And so we'll get 6x minus 2 minus 6x minus 12. What happens a lot that the leading terms cancel. If the degrees are the same, that's what usually happens. And we can combine negative 2 and negative 12 to negative 14 over 3x minus 1 squared. And that's it. So usually it's a couple of steps. Set it up, simplify it, get the final answer. Unless there is a little bit of simplification on the bottom, which we'll take a look at, which is y equals 3x minus 9 over 2x plus 4. And let's take a look at that one. First, we set it up exactly the same way. Put 2x plus 4 squared on the bottom. Now, derivative of the top, 3 times the original bottom, 2x plus 4, minus derivative of the bottom, 2 times the original top, 3x minus 9. Again, distribute the 3, so we'll get 6x plus 12. Now distribute negative 2, so we'll get negative 6x plus 18, I believe, over 2x plus 4 squared equals 12 and 18 combined to 30. Now, how do we can simplify it? How did I pull out a 4 here? Well, if you think about 2x plus 4 squared as 2x plus 4 times 2x plus 4, and you can pull out a 2 out of each one of them. So let's say it's 2 times x plus 2 times 2 times x plus 2. So what does it give us? It gives us 4 times x plus 2 squared. So notice that's how I pull out 4. Or a quick way, when you pull out a 2, you square it. So from the parentheses. So we can cancel the 30 and the 4, leaving us with 15, but also the 2 in the bottom. And so that's how come we get this final answer. That's it for that one. Now, let's take a look at another product rule. So we basically alternate some of the questions on the homework, for example, that you do not need to combine. There's one exception that we're going to get to. But in a lot of these, we can just simply set them up as the derivative and leave it at that. Like, for example, here, we have 4x squared plus x times x minus x squared. Notice how derivative of the first one basically becomes 8x plus 1 times x minus x squared plus 4x squared plus x, and the derivative of x minus x squared is 1 minus 2x. And that's it. Similarly, here's one with a decimal, which we can take the derivative exact same way. 0.7 comes down. 0.7 minus 1 will give us negative 0.3 in the answer. And it works the same way. You could do it with negative exponents. Again, we set it up as the product. So let's take a look at it. Here's one that's a little bit more involved. I think that one we simplify. So let's take a look at that. So don't let it scare you. It works the same way as any quotient rule. We have 2x plus 4 squared on the bottom. Again, we may have to pull something out, so keep that in mind. What is the derivative of the top? Well, that's 6x minus 9. Negative 11 is a constant, so it's gone. Times 2x plus 4, original bottom, minus derivative of the bottom is 2, times the original top. Again, now you may have to, I think this one we do have to simplify, so look for that one in the homework. So we basically use FOIL. Notice how I did not combine anything. These are actual FOILs. 6x times 2x is 12x squared. Then 6x times 4 is 24x. Then negative 9 times 2x, negative 18x. Then negative 9 times 4, negative 36. And distribute negative 2. We'll get negative 6x squared plus 18x minus 22. Notice how negative 18x and 18x cancel, which is why it's nice not to combine right away. Maybe something will cancel. So we get 12x squared minus 6x squared is 6x squared. Here's a single 24x plus 24x, and then negative 36 minus 22 combined to negative 58. Again, just like previous problem, we can pull out a 4 out of 2x plus 4 squared, and we can pull out a 2 on the top. So notice it'll cancel with a 4 on the bottom, leaving the 2. So notice when we pull out a 2, we'll get 3x squared plus 12x minus 29 as the answer. And again, you can compare with Wolfram alpha, which is handy if you put in the derivative. Wolfram alpha. It's exactly as it sounds, like wolframalpha.com. So check that out, and there's apps, although those are paid, so I would just go on the website if you want the free copy or free version. Here's another one. I think this one is a trinomial by a trinomial, so we don't need to simplify the answer. So it's kind of nice just to set it up. Again, derivative of the top times original bottom minus derivative of the bottom times original top divided by the bottom squared. It's nice we don't have to simplify in this case, because multiplying a binomial by a trinomial, while it can be done, it can be a little bit time intensive or consuming. So we're not going to do that. And here's one. I think this one is another one that simplifies. Here's a product over quotient. Now we could have used FOIL and multiply it out. I believe I didn't. I actually used the product rule to find the derivative of the top, which is easy enough if you think about it. We'll get 1 for the derivative of the first product times original second one is x plus 1 plus derivative of x plus 1 is 1 times x plus 3 times the original bottom 3x minus 1. Again, it looks confusing, but I use the brackets and we'll see how that would simplify. And then minus derivative of the bottom 3x minus 1, which is 3, times the original top. So I did not multiply it out just to see what would happen. Again, you can take out of the parentheses, so x plus 1 plus x plus 3 would give us 2x plus 4 times 3x minus 1 minus 3 times x squared plus 4x plus 3. I guess it does make sense to multiply them there. And simplify them very much like in the previous. You can use the FOIL, then distribute the 3. So we'll get 3x squared minus 2x minus 13 when it's all done, divided by 3x minus 1 squared. If this seems too long, simply multiply them out as x squared plus 4x plus 1, and then divided by 3x minus 1. If that's easier for you, just do that. But I wanted to demonstrate that it does work to use different rules at the same time. Now here's a few applications at the end of this section. I think I'm going to do it in a different video, so I'll come back in a minute.